Hi guys, welcome back to my YouTube channel.
Hi guys, my name is John and these are my friends Jason, Liz and Taeyong.
And we're from class physics.
Today we're going to talk about DC generators.
Gonna sit down. Hey guys, I just dropped down from the pORtaL up there.
Hello there, my name is John and today I'm gonna explain about what is a DC generator. So basically, the DC generator is made out of an armature coil, two permanent magnets, a commutator, carbon brush, and most importantly, the load. The load is basically anything that consumes the electricity generator, like the fan, light bulb, or something huge, like the entire resident area. So basically, a DC generator is very useful since it can turn mechanical energy into electrical energy. How it works is basically the turning of the armature coil between the magnet with external force like the wind and induces EMF. Easy. Examples of things that uses a DC generator are the windmill, water turbine, and more. This cowboy Taeyong is gonna explain how the DC generator produces a steady DC output.
Alright, hi everyone, my name is Taeyong and today I'm going to explain about how a DC generator produces a steady DC output, yeah? But first of all, let's look at how a DC generator works before we move on to before I explain how a DC generator produces the DC output. This is something like a fundamental part of my presentation. So let's look, yeah. So here's the story. So here I created a storyline on how does a DC generator works, and this is the first part of my storyline, yeah. So first of all, voltage is induced in coils by the rate of change of the magnetic field through the coils as the machine rotates. So why is it so? So because this induced voltage is inherently alternating in form since the coil flux increase and then later it decreases again with a zero average value. Now notice the word zero average value. So zero average value basically just means that there's no average value of a complete cycle, because remember DC generators, the graph is always above the x-axis. It doesn't change. It is not a sine graph like an AC generator. Alright, so this is my next part, my storyline. So the field is then produced by the direct current in field coils or by permanent magnets on the stator. Then the commutator connects the rotor coil to the stationary output terminals through carbon brushes. Now the word rotor coil might be something new to you all. So let me explain what is rotor coil. Rotor coil just basically is a mechanical device consisting of the stationary part of a motor or generator in or around which the rotor revolves, yeah. So after this, this commutator reverses the connections at the two instants in each rotation when the rate of change of flux in the coil is zero. For instance, when the enclosed flux is maximum or minimum. Alright, it's positive, negative. So this is my next part, my storyline. So the output voltage is then unidirectional, but is pulsating for the simple case of one rotor coil. Okay, unidirectional basically just means that it's going at one direction only. It's not going at multiple directions. Alright, so this is a very important concept, yeah. So then each coil is then connected to a segment on a multi-bar commutator. Okay. Later, the output voltage consists of the sum, and then the output voltage consists of the sum, right? Consists of the sum of the induced voltage in a number of individual coils displayed around half the periphery. Okay, periphery might be something very new to all of you. So periphery just basically means that the outward bounds of something as it is distinguished from its internal regions or center. It basically means that if you imagine it as a circle, it's just the perimeter of the circle. That is called periphery. Yeah. Alright, here's my next slide, my next part of my storyline. Now, the magnitude of the output voltage is then approximately constant, containing just only a small ripple. Okay, why it just contains small ripple? This is because the voltage magnitude is proportional to the rotor speed and the magnetic flux. To be exact, is directly proportional. Alright. So at the end, the control of the output voltage is provided by control of the direct current in the view. Alright. So this is now I'm going back into the question. How this DC generator produces a steady DC output. Okay, let's look into it, yeah. Alright, first of all, the generator is referred to shunt excited. Okay, what is shunt excited? Shunt excited right here, alright, shunt excited basically just means that it's a type of direct DC generator on the basis of source of field current. Alright, you can refer to your DC generator diagram to have more information. It just basically means that the basis of source. Alright. Okay, now it has the later, and then it has the advantage of requiring no independent electrical supply. This is one of the advantages of DC generators. So because it doesn't requires independent electrical supply, so it also means that it doesn't require, so it means that it also can produce steady output. Alright, this is the one of the best parts of DC generators. Next, residual magnetic flux in the iron poles produces a small generated voltage as the machine is brought up to speed. Alright, so the consequences are it causes the field current that increases the flux. Alright, it increases flux and then it turns the generated voltage. And in turn, the generated voltage, let's say in that way. Alright, so later the voltage then builds up until saturation in the iron limits the voltage produces. So those who taking chemistry, you should be familiar of the word saturation here. Okay, saturation just means that the degree of extent to which something is dissolved or absorbed, for here is absorbed, yeah, absorbed compared with the maximum possible until the iron limit. So this is basically what it means lah. Alright, so it's also usually expressed in percentage. The unit is also usually in percentage unit. Alright, so at the end, the stable value of the generated voltage can be adjusted over a limited range by just adjusting the value of a resistor placed in series with the field coil. Alright, so with that I've finished my presentation.
Oh, hey. My name is Businessman, and today I have brought with me Michael Faraday and Emil Lenz from the past. They are going to be the one explaining on how the pORtaL works based off of their laws. Let me introduce you to Mr. Faraday. My name is Michael Faraday, and today I will be explaining about my law, Faraday's law, obviously, and how it is related to the pORtaL. So basically, DC generators produce electrical power based off of my law. Since it is my law, I am the one stating that when a conductor moves in magnetic fields, in which this case the conductor being a pair of scissors, it cuts magnetic lines of force. Cutting through the magnetic lines of force will then induce an electromagnetic force, also known as EMF, in the conductor. It is also a law stating that when the magnetic flux linking a circuit changes, an electromagnetic force is induced in the circuit. An electromagnetic force induced in the circuit is actually proportional to the rate of change of flux linkage. Thank you very much, Mr. Faraday, for that enlightenment of your law. Now, let us please welcome Mr. Lenz to explain his law, Lenz's law.
Good morning everyone, my name is Emil Lenz and today I'll be giving you a brief introduction to my amazing law. My law determines the direction of an induced voltage or current along a circuit. Induced current or current running through the coil of wire creates a magnetic field. An induced current flows so that the magnetic field opposes the change in magnetic flux through the loop. Well, that's all I have. Thank you.
Thank you very much, Mr. Lenz, for explaining your law.
Good morning, guys. Today I'll be giving you a better explanation on how Faraday's law and Lenz's law apply to the flux over time graph and the EMF over time graph. So here I have two permanent magnets. The magnetic field is moving across from the north pole to the south pole. We have an armature coil in the middle with the current flowing in the clockwise direction. Here I have three graphs: the flux over time graph, the change in flux over time graph, and the EMF over time graph. So at the beginning, the armature coil is placed parallel to the magnetic field and the normal is perpendicular to the magnetic field. And according to this formula, the area enclosed by the armature coil is at its minimum, which means that the flux, since the area is at its minimum, the flux will also be at its minimum. This is why the graph will start from 0. As the armature coil moves in a 90-degree rotation, the area enclosed by the magnetic field increases to its peak. And as it continues to rotate into a full circle, the area enclosed by the armature coil will continue to increase and decrease. And this will be how the magnetic flux over time graph will look like. Next, I'm going to talk about the change in flux over time graph. And for this graph to work, we will need Faraday's law's formula, which is EMF equal to the change of flux over the change of time. This is also the gradient of the flux over time graph. So, as the flux starts from 0, the gradient is at its maximum positive value. Therefore, the change in flux over time will be at its maximum positive value. As the graph goes up, the gradient will slowly reduce to 0. Therefore, the change in flux will be at its 0 point. As the graph goes down, the gradient will increase to its highest but in a negative value. Therefore, the change in flux will go below the x-axis. And as the flux goes up again, the gradient will increase and reach its maximum value. Therefore, the change in flux will be at its maximum value. And this will be how the change in flux over time graph look like. Now, according to Lenz's law, EMF will be equals to the negative of the change in flux over the change in time, which means it is the negative of the gradient of flux over time graph. So all we have to do is take the change in flux over time graph and put it into a negative value. So at the point where the change in flux is at its positive, the
EMF over time graph will be negative, and it goes on for the entire graph, and this will be how the EMF over time graph look like. The end.
Hello everybody, today I'll be talking about a company called Integral. They are a company that managed to modify marine engines so that they become more efficient and cost-saving. Marine engines have DC generators and battery systems which supplies the shipboard's needs. Marine equipment such as navigation and communications equipment are also designed to operate on DC power. So Integral basically replaces standalone generators by using spare capacity from existing inboard engines. These engines generate up to 9 kilowatts of electrical power without compromising your engine's performance. It saves fuel for up to 25% and it powers at optimum efficiency. This engine also warns you when the batteries need recharging. The engine is always running at its most fuel efficient. This is only one engine, runs on 2 jobs, and uses less fuel. This engine works in the background, so it has no direct input from you. This shows that there is no maintenance required, so it saves fuel and also maintenance costs for its whole lifetime. It uses spare capacity to generate electrical energy for immediate consumption, or you can use it to charge battery banks. The permanent magnets in the rotor improves internal magnetic coupling, so it delivers high power and also high efficiency. They use direct current because it allows them to generate usable electrical power regardless of the rotational speed of the generator. It is very flexible in management and is directly compatible with any battery storage. 48 volts is chosen and it's considered as low voltage, so it is very safe to handle. Even if you accidentally touch a live terminal, it won't harm. This also allows them to use relatively small diameter cables, so they are less expensive and they are physically easier to install.